are reading this sentence right now.
And that single fact, that you can decode abstract symbols into meaning inside your skull, is the product of 6 million years of relentless biological pressure. Your brain is the most complex object in the known universe. And it almost stopped getting better. Not because evolution ran out of ideas, but because something happened around 50,000 years ago that changed the rules entirely. And once you understand what that something was, you will never think about human intelligence the same way again. Let's go back. For the first 4 million years of human evolution, change was brutally slow. A slightly larger brain here, a more efficient jaw there, a subtle shift in the angle of the pelvis that allowed for a longer stride. Each modification took tens of thousands of generations to spread through the population. Natural selection is patient in a way that is almost impossible for a modern human mind to comprehend. It does not plan, it does not hurry, it simply keeps what works and discards what doesn't, one generation at a time.
Across timescales that dwarf everything we think of as history. Then, something accelerated. Between 800,000 and 200,000 years ago, the human brain nearly doubled in size. No other organ in the history of life on Earth has grown that fast, relative to body size, in that short a window. Paleoanthropologists call it one of the most dramatic biological transformations ever recorded in the fossil record. The skull expanded, the forehead pushed forward. The regions associated with planning, language, and social reasoning ballooned far beyond what any primate had ever developed. The pressure driving this was real and merciless. Ice ages came and went. Forests became savannas. Reliable food sources collapsed without warning. The environments early humans lived in were not stable. They were constantly shifting, constantly eliminating the individuals least capable of adapting. And adapting for a slow, clawless, medium-sized primate with no natural armor and mediocre night vision meant one thing above everything else: thinking faster than the problem.
So the brain grew and grew and grew, and then it stopped. The modern human brain is roughly the same size it was 100,000 years ago. In fact, there is credible evidence suggesting it may have slightly decreased in volume over the last 10,000 years. Not dramatically, but the direction is not up. For a species that defines itself by its intelligence, that is a deeply uncomfortable fact to sit with. So, what actually happened? The standard explanation is that we simply reached good enough. A brain capable of language, long-term planning, causal reasoning, and abstract thought gave early humans such an overwhelming advantage over every other species that the brutal pressure to keep growing simply disappeared. There were no more competitors pushing back. The game was won. That explanation is technically accurate, but it completely misses what actually changed beneath the surface. Around 70,000 years ago, some researchers push it to 100,000, something shifted in human behavior so suddenly and so completely that archaeologists gave it a name.
They called it the cognitive revolution, and the evidence for it is written in stone, bone, and pigment across every continent humans had reached by that point. Before this moment, human beings had been making the same basic stone tools for hundreds of thousands of years. The Acheulean hand axe, a teardrop-shaped stone tool, appeared roughly 1.7 million years ago. For over 1 million years, it barely changed. The same shape, the same technique, generation after generation after generation. Then, almost overnight in geological terms, everything changed at once. Humans started making art. Cave paintings in Indonesia, dated to at least 45,000 years ago, show detailed animal figures alongside abstract symbols that no one has fully decoded. Humans started making jewelry, shells collected from coastlines 20 kilometers away, pierced and strung into patterns that served no survival function whatsoever. They started burying their dead
with intention. Red ochre, flowers, tools placed beside the body.
Objects that mattered to the living, sent with someone into whatever came next. They started looking up at the night sky and building stories around what they saw there. None of this helped them catch prey. None of this protected them from predators. None of this directly fed anyone. And yet it spread. Everywhere, rapidly, across populations separated by thousands of miles and natural barriers that should have made contact nearly impossible. The question that haunted researchers for decades was, why then? Why that moment? The brain had been roughly this size for 100,000 years before the cognitive revolution. What triggered the shift? The leading hypothesis today is not about brain size at all. It is about wiring. Some researchers believe that a series of small genetic mutations altered the internal connectivity of the human brain without changing its overall volume. Not more brain, a differently organized brain. One that could suddenly do something it had never fully done before. Connect unrelated things. Language is the clearest example. Every animal communicates. Bees map the location of flowers through dance. Vervet monkeys have distinct alarm calls for different predators. Chimpanzees can learn hundreds of symbols and combine them in limited ways. But no other species does what humans do with language. Humans do not just name things. Humans embed things inside other things. We say, "The red stone near the tree, where my grandfather's brother killed the lion 3 summers before the long drought." We layer time, relationship, place, and event inside a single sentence. We talk about things that do not exist, things that happened before we were born, things that might happen after we die, things that are entirely invented. That capacity to speak fluently about the non-present and the non-real changed everything, because it made something possible that had never existed before in the history of life on Earth: cumulative culture. Before the cognitive revolution, knowledge was trapped inside individual skulls. One brain, one lifetime of hard experience, one death, and most of what that brain had learned died with it. A hunter who discovered a new technique for tracking migrating herds could demonstrate it to the people around him. But the precision of that transmission was limited. Imitation only carries so much information. Language precise enough to describe the non-present changed the equation completely. A grandmother could warn a grandchild about a drought pattern that repeated every 30 years. A cycle no individual lifetime could have observed twice without that transmission. A healer could describe the properties of a plant found 2 valleys over to someone who would never travel there. A navigator could explain a coastline he had never personally sailed based on descriptions passed through 3 other people. Suddenly, one brain had access to the accumulated experience of every brain that had come before it. The group became a single cognitive system. And that system could do something no individual brain ever could. It could learn across time. This is the moment evolution changed address. It moved out of biology and into culture. And culture evolves at a speed that makes biological evolution look frozen. A genetic mutation that improves cognitive function by a measurable amount takes thousands of generations to spread through a population. An idea, a better technique, a new tool design, a more effective hunting strategy can spread through an entire network of connected groups in a single season. The brain didn't need to keep growing because it had found something better than growing. It had found other brains. But this shift came with a consequence that nobody anticipated. And it is the consequence that matters most for understanding where human evolution actually went next: dependency. For the first time in the history of life on Earth, individual survival began to depend less on individual biological capability and more on access to the group. A human being stripped of language, community, inherited knowledge, and shared tools is one of the most physically vulnerable large mammals alive. No speed, no natural weapons, no armor. A gestation period that produces offspring completely helpless for years. A liability no other primate carries to the same extreme. What kept early humans alive was not biological superiority. It was each other. And once that became true, evolution noticed. The selection pressure shifted. The traits that began spreading through human populations after the cognitive revolution were not stronger muscles or sharper individual cognition in isolation. They were social traits. The ability to read the emotional state of another person from a fraction of a second of facial movement. The capacity to feel genuine distress at the suffering of someone outside your family. The compulsion to share food, information, warning, and stories with people who cannot immediately repay you. The instinct to build reputations, to remember who helped and who didn't, to enforce fairness in groups of strangers. The human brain didn't stop evolving. It started optimizing for something different. Connection over computation, network over individual, trust over raw processing power.
And here is where the story stops being history and starts being a question about right now. Because if evolution moved from biology into culture 50,000 years ago, and if the traits most amplified since then are social rather than individual, what happens when culture changes faster than humans can track? The Flynn Effect is a well-documented phenomenon. Average scores on IQ tests rose steadily throughout most of the 20th century across industrialized nations. The explanation most researchers accepted was environmental. Better nutrition, more years of formal education, greater exposure to abstract problem solving in daily life. But in the last 2 decades, something reversed. In Denmark, Norway, Finland, the Netherlands, and France, countries with strong education systems and high living standards, average IQ scores have begun a slow but measurable decline. Researchers are still debating the causes. Some point to changing educational priorities, some to nutrition, some to the demographic composition of test populations. But one hypothesis keeps resurfacing. When a species consistently outsources a cognitive function to its environment, the biological infrastructure maintaining that function internally begins to quietly relax. It happened with navigation. Studies of London taxi drivers who spend years memorizing the city's layout before GPS existed showed measurable differences in hippocampal volume compared to the general population.
The region of the brain responsible for spatial memory was physically larger in people who used it intensively. GPS did not just change how people find locations, it changed the development of the organ that used to handle that task. It happened with memory. Before writing systems existed, human cultures maintained extraordinary oral traditions, legal codes, genealogies stretching back dozens of generations, astronomical observations spanning centuries, agricultural calendars precise enough to reliably predict planting seasons. All of it held inside human minds, because there was nowhere else to put it. The moment reliable external storage became available, that internal capacity began to fade. Not because humans became less intelligent, because the pressure to maintain it internally disappeared. We are doing it now with reasoning itself. This is not a catastrophe. It is not even unusual. It is what evolution has always done. Every time a species develops a reliable external solution to a biological problem, the biological machinery maintaining the internal solution begins to quietly downscale. Energy is expensive. The body does not maintain what it no longer needs. The question is not whether this is happening. The question is what the freed capacity is being redirected toward. For the first 100,000 years of modern human existence, the answer was connection, social intelligence, the ability to build and sustain the networks that made cumulative culture possible in the first place. The humans who survived were not the ones with the largest individual brains. They were the ones other people wanted to keep alive. 6 million years of pressure built the most complex object in the known universe inside a 3-pound structure behind your eyes. And then that object discovered something that changed everything. It did not have to carry the weight alone. That discovery did not end human evolution. It pointed it somewhere new. And where it points next depends entirely on what we choose to do with each other.